This is Honors Algebra 2 Pre-Calc. We're doing section 1.2 in Algebra 2, which is slopes and intercepts. So one thing you'll notice the second you open your book to 1.2 is that we've already done a bunch of the stuff from 1.2 because I'm not really good at working in order. I just kind of tell you stuff when it makes sense to tell you stuff. So in 1.1, we already talked about how to calculate slope as the rise over run, meaning it's the y2 minus y1 over x2 minus x1, or change in y over change in x. And we also went through the forms of the linear equation. Specifically in 1.2, we're going to see y equals mx plus b, which is slope-intercept form, and ax plus by equals c, which is standard form. We won't actually see point slope, which is the best of the three in my humble opinion, until we get to 1.3. So that'll be the next section, but again, I've already covered it with you. So still to come in 1.2, the stuff that we haven't done yet, are some examples in practice of the skills that we talked about in 1.1. Graphing by intercepts, which is a particularly useful skill when you're stuck with that annoying standard form equation. Graphing by intercepts is super dope if you're stuck with standard form. And then horizontal and vertical lines, which we did also sort of just talk about briefly, like I mentioned them in 1.1, but didn't actually cover them in any way. So let's start with example 1 on page 13 of the textbook. We're going to find the slope of the line containing the points 0, 4, and 3, 1. So now one interesting thing, so sometimes you'll have a math teacher that tells you that like this has to be the second point and this is the first point, so it has to subtract in this direction. It actually doesn't matter which direction you subtract in as long as you do so consistently. So it doesn't matter which point you call x2, y2, and which point you call x1, y1. That's completely arbitrary as long as whichever direction you choose to go in, you consistently do that. So I usually draw an arrow for that because I have a really bad attention span and sometimes forget what I'm doing halfway through a problem, which I'm sure you'll pick up on in some of these videos. So I will show you both directions if you want, just so that I can prove that it doesn't matter, but I'm going to subtract. I always like my y values to come out positive, and I have no good reason for that, but I'm going to subtract this way. So I'm going to do y, which is the 4, minus the other y value, which is the 1, over a 0 minus a 3, right? And if I do that, I get a 3 on top of a negative 3, or a slope of negative 1. So my answer is that the slope is negative 1, but just in case you're sort of a naysayer and you're like, come on, Hogan, I don't believe you, I can't subtract the other way. The other way to get that same answer, and I promise it does exactly the same thing, is if you had subtracted the other way, if you'd gone this way, it would have been 1 minus 4 on top and 3 minus 0 on the bottom, and there's your negative 3 over 3, which is totally also a negative 1, right? So it's also a slope of negative 1. It really doesn't matter which way you subtract. It just matters that you do it consistently, right? So if you're always going from this point to this point, you have to do that in both cases. So as usual, if you don't want me to do P1 before you get to try, you should pause the video and try P1. P1 is exactly like E1. It is also on page 13. It says try this. So we're going to find the slope of the line containing the points negative 5, 3, and 3, negative 4. So I'm going to go ahead and do this, and if you don't want to do it, then you don't have to. So again, you can pause and just whatever, or you can just watch me do it. I don't care. Up to you. So I like my y values to come out positive. I have no good reason why. It's just a preference. So I'm going to go this direction and do 3 minus a negative 4, which will come out as a positive 7. And on the bottom, I'm going to do negative 5 minus a 3, which will come out as a negative 8. So I get 7 over negative 8. And that's my answer. Now, I want to point out that there are 3 different ways to write this, and they're all correct. You could write it as a 7 over negative 8. You could write it as a negative 7 over regular positive 8. Or you could put the negative in the middle of the fraction so that it's not really with either number. What you can't do is make them both negative because that would make them positive. So it's not this. This is not okay, right? Sorry, I'll inch you over a smidge so you can see that. That one's not okay, but all of these are totally okay, right? So any of those are totally fine, not the negative 7 over negative 8. Cool? I think most of us kind of default to putting the negative on the top, which is fine, which makes it all the weirder that I stubbornly insist on my y values coming out positive when I find slope. But here we are. Cool. All right, let's keep moving. So the second skill that we're going to talk about, and then we'll probably stop this so that you don't have like super duper crazy long videos. The second skill that we're going to talk about is we're going to talk about graphing by intercepts, which is super useful when you're asked to find a graph for something in standard form, which again, I'm not going to do to you very often, but like there are teachers that will, and so it's worth knowing that this is a thing. So let's talk about what the intercepts mean. So to intercept something is essentially to run into it, right? So when we talk about the y-intercept, which for the record is b in the mx plus b, right? So it's b. The y-intercept happens when x equals 0, okay? And the x-intercept happens, right? So the x-intercept, which also has other names, so we'll talk about that in a sec. The x-intercept is sometimes also called a 0 or a root, okay? And that happens when y equals 0. So what we can do is we can use this information to, in standard form especially, to quickly find the x and y intercepts. So just to show you what I mean by that, right? So I'm going to walk you through a fake example here just to show you what I mean. Okay, so let's put something in standard form. Let's say I do 2x plus 3y equals 6. Hopefully that's not directly from one of the ones that's in the problem. It's darn close, but it's not exactly the one that we're going to see. So 2x plus 3y equals 6. So one way to graph this would be to solve this by solving for y, and then I would have something in slope-intercept and I can graph. But if I asked us to find the x and y intercepts, so if I ask us to find the x-intercept and the y-intercept, right, if that's the task I ask you to do, right, in order to find the x-intercept, what we're going to do is we're going to plug y equals 0 in, and that's going to be the place that the graph intersects. So if I just elaborate up here a little bit, when x is 0, the graph hits the y-axis. That's why it's called the y-intercept. And when y equals 0, the graph is going to hit the x-axis, okay? So if I wanted the x-intercept, that would be when y equals 0. What I would do is plug in y equals 0, and I would get 2x plus, if y is 0, this is a plus 0 equals 6, so I would get x equals 3, meaning that the point 3 comma 0, right, is the x-intercept. If I wanted the y-intercept of this function, I would plug in x equals 0, so that would be 0 plus 3y equals 6, and I would get y equals 2. So the y-intercept is 2. So what I want to show you about this is if you wanted to graph this, you could, because the x-intercept is 3 comma 0, and the y-intercept is 0 comma 2. So this is the point 3, 0, and this is the point 0, 2. Well, if you know those 2 points, you can graph the line just by connecting the dots of those 2 points. So that's what we mean when we talk about graphing by intercepts. So again, the important piece of information to take away is that what it means to be the x-intercept, right, because this is the x-axis, so the x-intercept happens when the graph intersects the x-axis, and the y-intercept, because this is the y-axis, happens when the graph intercepts the y-axis, okay? So again, we have our x and y intercepts, and that's what the graph would look like. So we're going to go ahead and work through some examples like that in a little bit, but that's the idea of finding the x and y intercept.